Okay, cool. I will start recording. Welcome, folks. We are chatting about DRA integration into Karpenter. We are meeting on behalf of SIG Autoscaling and the CNCF, so thanks in advance for abiding by the code of conduct. Without further ado, Jason, you were announcing the merge of Node Overlay and Karpenter. That's great. Um, Feel free to add any other color to that if you'd like.
Yeah, I don't think there's too much to add. So this is just the V1 Alpha 1 version of Node Overlay. We're already anticipating making breaking changes to it, so us building onto it for DRA is totally acceptable and within expectations. So now that that's merged and finalized, I've started work on a POC with it. Um, but yeah, we should be able to actually start finalizing some API shape and such for the RFC. So yeah, this next week and a half, my bandwidth is really tight, but I'm hoping to have that up the week after. And then working on the POC kind of simultaneously, just to get an idea if the API design I'm proposing makes sense.
Oh, when you're talking about that, are you talking about like adding resource slices into node overlay?
Yes, yeah, as far as
Okay.
the API design goes. When I say POC, though, I'm talking about all of it.
Oh,
So the actual scheduler integration,
oh, gotcha. Okay.
which requires that that be built as well.
Okay. Um, that was actually one of my questions was should we like that should probably be done before the DRA clock driver for Carpenter, right?
I actually don't think so. Um,
Okay.
I think we can work on that basically independently. And
Okay.
if
That
anything,
makes
it'd
sense.
be very valuable for it to be ready pretty early in the process so we can use it for testing.
Okay. The only thing, okay, so I edited RC again where like case one is like because our primary use case is going to be using node overlay, right? And then after that, if like we don't find the associated resource slice with node overlay, then we would use the config map, right?
Mhm.
Okay, so I guess I was trying to figure out what exactly node overlay would look like with resource slices inside of it. Would it just be like this, where we just like actually put the resource slices in it?
There is potentially a little bit more than that. The main thing is
Okay.
a way to express, um, we need a way to express like the node selector accurately. So the issue being, uh, let's give an example of, say, you have a resource slice that's just available to all nodes within one availability zone. Um, we basically need a way to express that it's available within the same availability zone as whatever instance is created for it rather than a specific one. And maybe we need a way to differentiate between like a dynamically resolved topology requirement versus a static topology requirement.
Um,
So it's probably not going to be quite as simple as just copy pasting the spec over, but it will be relatively similar to that, I think. I don't think it makes sense to differentiate on it too much because, of course, that's the spec that people are going to be familiar with. I don't think we want to totally make something custom, but we will need to extend it a little bit to support those types of use cases.
mm, Sorry, I was trying to find the link. Wait, can you repeat why it's more complicated because if we have a resource slice available to all nodes in one availability zone, then what?
So the example I was giving was when you create an actual resource slice, all of the topology requirements are going to be resolved. Like if
Okay.
it has a host name requirement, you know what the host is. If it has an AZ requirement, you know what AZ or what set of AZs it can be used in. With Karpenter, that is all going to be relative to the instance type that we provision, typically.
Right.
So we need a separate way to express that. So you need a way to basically say, rather than saying like, this resource slice is going to be available in US East 1A, it's going to be available in whatever AZ the host device or like the host node is created in.
Okay. Um,
So more than likely, kind of what I'm thinking is we can basically have a cell expression inside the selector where you have something like instance.zone or node.zone, something along those lines. But I'm still thinking through exactly what that needs to look like.
mhm.
Do we have enough of an idea? Because it sounds like we don't exactly know how this is going to look, and we don't have a design doc right now. But do we have enough of an idea where we could get started on the DRA Quack driver work, Alima, or do you feel?
Oh, yeah, I started a RC.
Oh, okay, got it. Okay,
I just added it to the doc.
Well, that's where I was thinking we build out the config map version of it first,
Yeah, okay. That
because
makes
that doesn't
sense.
have any requirement on the node overlay design. And
Um,
that's enough of a primitive for us to start testing with it and start development with it. And then once the actual node overlay design is finalized, we can begin working to integrate that.
okay, that sounds good. Yeah, because when you're I think I'm still confused um on what you're trying to say about how it's more complicated. But I feel like we can go into that later.
Complicated isn't the right way to put it. I don't think it's particularly complex.
Uh-huh.
It's just different.
Okay.
So yeah,
Or I
basically,
feel like I'm not understanding it is what I'm trying to say.
basically,
I think like the resource slices matching logic
Yeah.
is not exactly the same as how no overlay matching logic. They don't mesh together directly. So there's some weird mapping that has to happen in between, I think, right?
Okay.
kind
The-
of, it's more so like the node overlay matching logic is
Like instance type.
matching against instance requirements, and then, but not topology requirements necessarily. Whereas the resource slice requirements are for any node that matches the requirements on the node overlay, we will create a resource slice which has its own topology requirements, which is basically saying pods on any nodes which match these topology requirements can consume devices published by this resource slice.
Okay. I see what you're
Oh,
saying.
okay.
So, but the topology requirements of the resource slice typically are going to be a function of the topology requirements of the node that provisions it, or the node, like the node that actually hosts the device. So like that's where the example I was trying to give with like AZ was you can imagine a hypothetical scenario where you have a device that can be used by any pod on any node that's in the same availability zone. That device is still hosted on a node. So the idea would be we bring up a node. We don't necessarily know at provisioning time which AZ the node is going to be in, but we know that any pods that happen to be co-located with that node will be able to use the device on that node, like co-located by AZ. So it's just adding like a small layer of dynamic. I'm trying to say like dynamic
dynamism.
dynam I still can't say
No.
that for some reason. But yes, that. Adding a small layer of that on top of the node overlay
Okay.
selector requirements.
But doesn't
Uh,
does does that require a node overlay spec change? No, right? It's just a logic behind the scenes.
No, this would be, I mean, it requires a node overlay spec change in that we're going to have to extend node overlay to support resource slices.
Sure, sure.
This is going to be part of like the resource slice definition. So it's kind of the difference between like I forget the resource group for resource slices, but whatever the V1 CRD looks like, or not a CRD, but you know what I mean, the
Mhm.
resource. And then whatever we embed into node overlay.
okay. Yeah, what I had for the DRA clock driver for node overlay, I literally just put in the resource slice like objects.
I
But
think
yeah, but that
more or
can be
less what it's
changed.
going to look like for what it's worth. I
Okay.
think the only difference that I foresee it having is as part of that node selector that the resource slice defines, we're going to have some way to dynamically say like this resource slice will be available within the same zone as the node that provisioned it.
hmm
Like I guess for a more concrete example with like the NVIDIA GB200 instances, I forget the name of the topology that they're available in. I think it might be like a click. Like all of the nodes have to be in the same click for you to be able to share resources across them. So the idea would be that you say on your label selector, you have that click requirement, and it's like whichever node is in the same click as the node that this device is provisioned for. And then once the node is actually provisioned, that will presumably resolve to like some concrete click ID. Click might be the totally wrong word. I'm pulling from.
I think click is a low level word. I think IMX channel is the top, unless that's not the same thing. Click is
They're
definitely a thing. I've seen it.
closely related. I think you can have multiple IMX channels within a click. I'm not entirely sure though. They're definitely closely related.
Okay. Let's go over the config map case for everybody.
So click through this.
Yeah, if you don't mind opening it for me.
Oh no, of course not.
I realized I was showing my screen thinking I was sharing my screen. But
Case
yeah,
2 right here.
yes.
Can folks see my screen?
Yep.
Yeah.
Okay, cool.
Yeah, if you go down to how it works, it's probably better
Cool.
right there. Yeah, but basically the actual Quark test would define the config map because I'm assuming every test might have like different config map needs. And then when Carpenter does create a Quark node, and then it doesn't find the node overlay match, then it would use the config map. So then our new Carpenter DRA Quark driver would create the resource slice based on the config map, and then the config map is basically just mapping node selectors to resource slices. So, let's see. Yeah, and then after the resource slice gets created, then it just goes through the test. Like scheduler sees the resource slices, tries to schedule the DRA pod, and then the test like validates with that. But let me see.
When it comes like to vending logs, B3 value and S3 and 5, do they first go to cloud of ingested and then send it to 5?
Yeah, that's really it. Matching node selectors to resource slices.
Yeah, I think this is generally what I was envisioning.
Okay,
So
but am I right to say that every test might have a different config map? Or like, I mean, maybe a series of tests would have like the same config map.
I think more or less, yeah, this would be
Okay.
something that, yeah, you either configure on a per test basis or if you're just manually testing, you've edited these config maps and
And one.
yeah, just go from there. It's
Okay.
similar use case to the node overlay. The reason I think that having both is valuable is because we will want to have some tests to ensure that Carpenter still responds correctly to resource slices that are created that it wasn't informed of via node overlays. Like we want to make sure that it successfully schedules against resources that were published out of band of it.
Mhm.
And so having that through the config map is valuable. Additionally, with the value of just being able to start development on this before the actual node overlay interface is finalized.
Mhm. Okay. In terms of the actual like files, like I feel like that's kind of valuable to understand where things would go.
Mhm.
We would have our own separate DRA qualk tests, right?
So yeah, I think like you showed, it would probably be just another file inside the integration test suite. Or maybe it has its own like DRA test suite.
Sure. Okay.
Um,
Um,
I think comments doesn't look like shows up in this view. I did have a comment on the
oh,
directory.
you did?
Yeah,
That's just because I think
If you
I think
click
it doesn't show up
the,
in the rich preview.
yeah, if you click the two bracket, yeah, right.
Yeah, because I did have a couple of comments I left. But
Oh, okay, cool. Thank you.
yeah, I think that the test suite part makes sense as far as directory structure for everything else. I think it makes sense to just have it live in like a separate top level folder,
Yeah.
similar to how we have the Quack cloud provider. And then if there is any shared logic that makes sense to have as part of the Carpenter upstream library, it can live there in the package, like that other top level package we have can consume it as a library. Again, similar to what we do with the actual Quack provider.
Wait, sorry. So you're saying that it would still be in uh
So like instead of being in Carpenter slash package, it'd be like in Carpenter slash Quack DRA driver slash package.
oh, okay.
So keeping the control logic
Okay.
separate. Any common logic that we want to have in upstream Carpenter, like I said, it can live there and we just consume upstream Carpenter as a library inside the DRA driver.
Sorry, I'm just looking right now. Wait, why would it not just be in test?
I'm
Or sorry, you're not are you not talking about the where the
are
our
you talking
DRA
about this
clock
part?
test?
Yeah, the
If you can
top
see
one,
my
not the
mouse.
test, the package part.
Oh, that
yeah,
part. Okay, okay,
as
sorry. I
far
didn't
as
realize you were
where
talking about
as far as where the tests live, we're on the same page.
that. Okay, okay, sorry. Can you repeat where you think the other stuff should go? I mean, one thing is like controllers.go, that should stay, right? Because that's where we need to register. Like,
Well, the Quack driver isn't, I don't think it's going to be part of the Carpenter installation, if that makes sense. Like what I was thinking made sense was having it as a standalone controller binary that you deploy to the cluster.
but for that to happen, don't you need like,
Uh,
don't you need to register that or like create the driver in the cluster? Like
Yes,
it would be separate from Carpenter for sure, but like you still need to create it.
well, in this directory structure, you wouldn't be making it separate from Carpenter. Controllers is where all
Uh,
of the like sub controllers within Carpenter live.
I,
So
I guess
all of them are part of Carpenter binary.
okay. Um,
you can think of
so it
Quark as like a separate provider, like Azure or AWS, but then Quark is just part of the main repo. But Quark
see.
is like a provider, you can imagine. So it's not
Uh-huh.
in the core library, it's slightly different, if that makes sense.
Yeah. Oh, actually, let
Yes.
me. This is going to be kind of maybe random, but let me provide an potential
Yeah, cluster API
example in
provider. Yeah.
Cluster API. So Cluster API. So I'm going to get there in a roundabout way because I'm bookmarked. Cluster API has a built-in test provider that is
I think you're not
embedded into the
sharing.
main repo, I think. Where is it?
I think if you pulled the tab off to a different window,
We're
you're
not seeing.
the
We're just seeing
original one.
Oh,
the
I'm so
Carpenter.
sorry. Did that happen? How did that happen? Ah. Let's see here. Let's see here. So Cluster API does something similar, I
It got
think.
moved off screen again.
Oh, wow. Why is it doing this? It's because I'm okay. I see what's going on. I'm going to use the Goog here. Am I here still?
Yeah,
You're
we
good.
see it.
Okay, cool. So I'm going to time box this to like 10 seconds. Can I find this? I think I can't, but I'm going to just plus one the idea that normally, so let's classify this as a provider, like if we want to be super strict about it. And normally providers live outside of the Carpenter main repository. But for a synthetic provider like this, it makes sense to keep it in the mono repo, so to speak, as a way of sort of optimizing for convenience. It's like tightly coupled to the core project because it's a test provider for the core project, and also signals to the community like this is not something you actually are going to use in the real world. Is that kind of what you're saying, Jason?
Yeah, and it's also one of those things like generally we want this to be available for testing to anyone that consumes this package.
Yeah.
So that's where I was originally thinking it doesn't even make sense to make it part of the Quark provider binary. Because, for example, we also want to be able to run like we built a Quark AWS provider implementation as well, which releverages a fair bit of the Quark work here. And so we have this fake AWS Quark provider, which calls fake AWS APIs. We would also like to be able to test that with DRA.
Yeah.
So having this as like a standalone, like basically we'll end up having like a Quark DRA pod. That is its own standalone binary running completely separately from the Quark controller.
Hmm.
Yeah. By pod, you mean like a CRD, basically.
Well, I was thinking it would be a pod inside the Quark cluster.
I see. Okay.
Like it would be its own controller runtime project.
Mhm. Okay, I understand that it should be its own controller runtime project. The existing Quark tests are not its own controller.
Well, this itself isn't part of the tests, right? At least not the way I've been envisioning it.
Or I agree, it's not part of the test right now, but like I'm just wondering how it is, right? Like for like I understand our thing is separate, but how is it working right now for Quark tests right now?
Well, so if we want to go back to the main repo page, we've got that Quark packet, that Quark folder, and
Uh,
that is where the actual Quark cloud provider implementation lives. So this is similar to
uh,
Carpenter provider AWS, Carpenter provider Azure, but it's just mocked out with like fake instance types and stuff for use with our Quark tests. And this is its own standalone project in a sense. It's still in the mono repo because like this is something that is part of the Carpenter project for Carpenter testing. But
mm,
it's not part of the Carpenter library that any of us consume.
okay.
So
Okay, thank you. Wait, but sorry, just to make sure I got this right, all the DRA Quark driver stuff should basically be like its own directory here, like not in package, just its own.
that's my thought.
Okay.
Yeah.
Sounds
So
good.
you would just insert one more child. You would replace, well, if this is the repo, then you would just create a new parent directory called, say, quack-dra, and then move all these as children and grandchildren directories into that parent directory.
You said SIG
So there's a
quack.
quack directory here. We can just add a new directory called quack-dra,
Oh, I
and then
see what
you
you're
can
saying.
put all
Yeah.
this stuff into that as a.
Yeah,
And of course, this is all going to change during the process, but that's
yeah.
probably a good start. And then the PR process
Okay.
itself will help resolve the final outcome.
Yeah, okay. That sounds good. I just have a comment for that. So
Yeah, I
I'll
think
do that.
the important thing is we just want it to be its own standalone thing that you can install in your cluster, like regardless of your Carpenter implementation. So we just want to decouple it from Carpenter. Like I should be able to go and I should be able to install it, manually create a node object and see it respond because it's living by itself.
Okay.
It has no dependencies on Carpenter itself.
Yes. Okay, perfect. Thanks. That makes sense. Okay, I feel like I'll edit this. I'll edit the RC one more time, but like I feel like I could just like start with the PR for this.
I think so.
Okay.
And like I said, I did leave some review comments. I don't think there was anything major. Uh,
Okay.
the only thing I did call out was I do envision there being a third way for cloud providers to interact with this, which is, I think we've talked about this before, but with node overlay, the way we view node overlay is essentially a backdoor to allow advanced users to inform Carpenter about the shape of their nodes based on configuration Carpenter is unable to parse. So
Mhm.
for example, the motivating thing for node overlay was being able to do stuff like support huge pages where it's some custom, in our case, AMI configuration that affects how many huge page resources are made available. So in this case, we're extending that to be resource slices as a whole. Now, I think long term, the ideal for most cloud providers is using their own APIs or their own knowledge of how different drivers interact with their particular instance types. They will be able to inform upstream Carpenter through the cloud provider interface what those resource slices will look like for each instance type. Now, users will still be able to override that through node overlay, like if they have some custom configuration. But ideally, we want to be able to drive to as little user config as possible. Like in our case for AWS, like we know you have a P548X instance. This has 8, I'm pretty sure, H200 GPUs. We know that you're running this version of the NVIDIA driver, which can partition them in this different way, or can create resource slices with this shape. So we're automatically going to send that over without you needing to configure node overlay. So I think long term, to support that type of use case with cloud provider implementations, we'll want some way for the cloud provider to inform the driver of what those resource slices look like. Now, maybe that just ends up being the cloud provider generating those config maps, and that's fine.
Not to
But
make things more complex, but just for fun, I will. If you are declaring like a very specific MIG configuration, is that so? What I really mean by that is that there's more than one way. There's more than one resource slice outcome for a particular instance type, depending on certain configuration inputs, and MIG would be one of those examples. And this is not a DRA thing; it's more the MIG configuration working in concert with the DRA driver to render a resource slice in a particular way that fulfills that MIG configuration. And sorry if other folks don't know what I'm talking about, but essentially, this would be a way to optionally expose 8 single GPU devices or a single 8 GPU device. And so MIG is the NVIDIA standard way of doing that kind of a particular sharding. So in that kind of a use case, I think I would imagine a node overlay is really your only option. Like you can't
I think it
for Carpenter.
depends. So
To be clear, this is just we're just hanging out at this point. Don't this would be scope creep if it were taken as like literal
oh, and this is
conversation, but I'm
actually
just curious to have this conversation. What's that?
this is absolutely stuff I'm viewing as a follow-up to initial like
Oh
MVP.
yeah, no, for sure. I just want to make clear
Oh.
it's not relating to the block config map node overlay conversation
Yeah, I
strictly.
think, well, I'm hoping generally, like based on the way that I've read the partitionable devices and consumable capacity caps, like it should be able to express all of the different ways that GPUs can be partitioned within a single resource slice. When that isn't the case, though, because I imagine there will be cases where, depending on your on node configuration, the resource slices generated for a given instance type with a given driver are going to be different.
Mm-hmm.
I think the main thing I'm envisioning, at least on a provider level, is okay, we're the one provisioning these instances, we're the one passing configuration to these drivers. For these commonly used drivers, we'll build out the way
That's
to
right.
configurations and intuit what these different resource slices will look like. That ends up being far more cloud provider specific because it requires a lot more knowledge about what the actual underlying hardware on the instance types are and how it interacts with those drivers. I would love to have a way to make that common to Kubernetes SIG's Carpenter and have all cloud providers benefit from it. I haven't been able to figure out a good way as of yet.
Yeah, I don't think there is a way for that because like even as we talk about this more and more, it seems clear that the pattern, the sort of legacy pattern where you have a more abstract representation of infrastructure requirements that can then be rendered across a huge combinatoric of instance types or VM types or whatever. Like that's already the default. That's like the base case for a Carpenter use case. So that's gonna carry forward for resource slices as well. So I can interpret DRA input and not only in some cases I should be able to actually fulfill that with more than one resource slice outcome, but also a single resource slice outcome can be achieved multiple ways. Like you could mix and match various instance types with various configurations and get the the um, the sufficient resource slice outcome that you want, like an equivalent resource slice outcome. So that it makes sense to me as well, following your thinking that all of that is outside of the scope of Carpenter Core. Like what's in scope is defining APIs that can then be flexibly used by the providers themselves. So only the providers are going to know how, like for example, one resource slice outcome, how can that be achieved, 12 different ways? Only the providers are going to be able to do that. I don't see how that would be a responsibility of the core. Hope
Yeah,
that made sense.
I mean, it's in line with what I've been thinking. It definitely gets tough in like with open source Carpenter because I don't know how locked down like the node configuration is in Azure provider. With the open source Carpenter provider, you can provide custom OS images, so it's
Yeah.
whatever.
So you could do the same thing in Azure as well. Yeah.
Yeah, I
There's
figured.
less flexibility with AKS, and probably the same thing applies to EKS. Like once you get to the managed Kubernetes, the configuration surface area is restricted. But in terms of Azure, yeah, you can imagine building an Azure Carpenter provider that was infinitely flexible.
Yeah, I mean that's where I envision for like things like EKS Auto Mode, where we are in full control over node configuration. We'll be able to build out better integrations because we know everything and we are in control of everything. But it definitely gets a little bit more challenging when you're talking about like the open source providers that you can just run on standard AWS, and you can run literally any operating system you want with any set of configurations, and Carpenter doesn't know anything about it.
Yeah.
That's why I think we'll always need this backdoor of node overlay. So users who do these more advanced configurations can inform Karpenter of, I know what I did to this node. I know it is going to create this resource slice, simulate against that. But of course, that ends up becoming quite a bit of configuration if that's the only way to do it.
Real quick, just to interrupt about housekeeping stuff, because I think Mark has to drop soon, but it would be really, really helpful if we could get a roadmap, not only for new contributors, but also like for me, because I think in general, everyone's struggling to understand the bigger things that we need to work on. Like right now, we know what to work on for right now, but what I think there's like steps after that that's a little black boxed. I see in the RFC, all we have is the proposal, and then with that, there's like some steps. But I think it would be nice to have like an actual like roadmap. How do we feel about that, and how could that, what exactly that could look like, whether it's a GitHub board or just having it on the Google Doc?
Yeah, I think I potentially have some time to help out and things like that too. I'm not really sure where to get started though, or if there's like what's kind of what the community wants, like where they want to take this.
It's where
Right.
it's still hard for me to say at the moment because I'm still just starting like the POC process to kind of understand what parts can be split out. My focus over like the past month has been helping with getting a couple of the other milestone larger features for Karpenter out, one of which was node overlay, which was blocking this.
Yeah.
So now that both of those are pretty well in, node overlay static capacity, I can pretty well dedicate time to this. So I'm hoping, like I said, probably not by next week, but in 2 weeks, I should at least have been able to build out some of that POC, part of the RFC, and start figuring out what those like separate, I guess, separatable tasks look like.
Mhm. It doesn't, I think for right now, it doesn't have to be super detailed, just like it could be abstracted away where it's like, I just like, I feel like just like a little bit of overarching structure would be good.
I think right now I can kind of see 3 parts, which is node overlay integration, scheduler integration, and then the test driver. Those
Okay.
3 are very high level. Um, I think scheduler integration will be able to break down quite a bit more,
Yes. Okay. Perfect.
but I don't have anything codified at this point.
But those are actually separate enough where you could imagine a epic issue for each of those, which could then be decomposed as more of the scope is observed, and then like we can figure out what individual work items can be sort of spawned from those. But I think those are going to be durable.
Mhm.
It sounds like the node overlay integration probably maybe that's a simple.
Yeah,
Is there already an issue for that?
there isn't a specific issue, no. Yeah, and it
So
does.
normally we'd like RFC lands, and then now we just have to implement what the RFC states, that kind of a thing, right?
Yeah.
Yeah.
Yeah, I think this is where I will admit, like the development process and the RFC process we have had for Carpenter has started to break down a little bit on some of these larger epic issues because it has up until this point been one RFC, one implementer, and usually 1 or 2 reviewers. Um, so I'm definitely still trying to learn what the best way to scale out the development process for these larger epics are.
Well, I think if, with your permission, Jason, we could just create a placeholder epic issue for the node overlay, even though it's probably not an epic node overlay integration. We could create a placeholder issue for DRA scheduler integration and a placeholder issue for the Quark test driver. We could then create simple GitHub project board with those 3 issues and just begin the process like in a crawl, walk, run kind of way of managing the scope of work.
I think that makes sense. I've not used GitHub project boards before. Is that just like a Kanban board?
Yeah, we can help out with that. We've got lots of experience.
Okay.
It's
Yeah.
built into GitHub, so
I thought most of the SIGs use GitHub project boards,
yeah,
like
for sure. No,
SIG Node does. Okay,
it'll be easy to do that. Yeah.
okay.
Yeah. I've just never used it because we haven't used it for Carpenter. So
Yeah, cool. Maybe
What
you or
does
Mark could
Carpenter
pitch in
use?
there.
What does Carpenter use?
so that's like I said, for the most part, in terms of external contribution, it has been you make an RFC, the same person who
Oh,
implements the RFC, and it's all like self-contained to that one piece.
oh, interesting. Okay.
Obviously, that doesn't scale when you get to a larger project like this for DRA.
Yeah.
For our own, and most of the larger projects we have undertook for Carpenter have all been developed by folks at AWS.
Oh,
At
makes
least
sense.
for the larger projects that scope outside of more than a couple of PRs. So we have our own like project planning system, but that's we don't have that public.
Mhm. Okay.
So yeah, no, I'm definitely not against the idea of using GitHub projects. I just haven't used it personally before.
Cool. I think we have a path forward for that, and it'll be at least just some concrete excuse to start that effort. And I'm confident that we can help manage it. I mean, one of the things that I think that our folks are super used to doing is managing units of work across lots of different projects. And so maybe in a previous lifetime you've done that, Jason, in different roles. But right now you seem 100% focused on this super complex mission critical Carpenter project. So we're grateful to have you. But we are, I think, used to that kind of a habitat. We can just swarm and create a project board and then do a bunch of stuff on behalf of a customer need for a particular project, and then we can move on to another project. So that's a super easy thing for us to do right now. And if that adds value, that's great.
Yeah, no, I definitely see the value add. And we need some way to organize this if we want it to be collaborative, especially outside of just AWS and Azure. So
Yeah.
no, this sounds like a good plan to me. I definitely appreciate the help with it.
Yes.
Yeah, as far as breaking down those epics, the one I'm largely going to be focusing on is breaking down the scheduler integration side of things. I likely won't have anything for next week. Like I mentioned before, I'm on call this week, next week. So that is unfortunately most of my life for these 2 weeks. But the week after with those other big milestone projects, yeah, should be able to start making a lot of progress there.
Yeah, it's
Okay.
all good. I think that Alima, you have enough to
Yeah.
bang fingers on keyboards for a week with the Quark stuff. And maybe next week we can just present a super simple GitHub project board and provide some status updates, and tentatively plan for October being a more
Yeah.
high velocity month. That's all good.
Well, next week is team up, by the way, Jack. But
Oh yeah, our team is all meeting in Redmond next week. But
Yeah.
we'll make a little bit of progress, I bet.
yeah. So, anyways, we'll just come back the week after, I think, and
Okay.
talk.
Sounds like a good plan because, like I said,
It,
next
it lines up perfectly. Yeah.
anyway.
Cool.
So yeah, no, October, I do anticipate being very high velocity. I do want to get, at the very least, MVP version of this working, even if it's not merged by the end of October. So, and I think that is still realistic.
Yeah.
Cool. That'd be great.
Awesome.
As of now, you're still on the hook to come to KubeCon with me, Jason. So that'd be a really cool thing to have in the
Yes.
slide deck.
Yeah, I would really like to have a working version of it ready by then.
Yeah, cool.
don't think
So
I,
exciting. Thanks so much.
yeah, and great work on the RFC.
Oh, thanks. It was like a lot of I felt like I was thinking so hard, like, but I'm glad that it's somewhat done. And thank you for all the help from both of y'all.
Yeah, of course.
Okay, good luck with
All right.
on call, Jason.
All right, appreciate
All
it.
right. See y'all. Bye bye.
Okay.